Significance is something that you hear about all the time. You hear about it in the newspaper, you see it on Facebook, and if you read academic journals for fun, you definitely hear about it there. But what is significance and how do we interpret it? This is something which people make a mistake of all the time. I'm going to help you through by understanding significance, effect size, and everything about understanding what significance means. But I'm going to start by talking about distribution, which is the core of all statistics, and you need to understand this to understand all data out there. Now, if you take any scale we're going to measure people on, which is the amount of ice cream they eat in this example, some people are going to have 1 teaspoon of ice cream a year, a tiny amount of ice cream. There's not many of them. That's a very strange amount to eat. Very, very small people. Then you've got people who eat a load of ice cream, 1 tub of ice cream a day. There's not many of those either. So at both ends of the extreme, we've got small amounts of people, small amount eating a tiny amount, small amount eating a big amount. But somewhere in the middle, we've got people eating what's called the average amount, which is a range. Maybe the average is 5 tubs of ice cream a year. Now, does that mean that most people go out and buy 5 tubs? No, they eat a range. So you're going to have maybe 4, maybe 6 tubs in a year. Okay, so we have a range. And you'll find that about 66% of people are going to sit in that middle range of between 4 and 6 tubs in a year. Okay, that's the average amount. So that average number is just the middle of that defining group. Now, we start up over here at the extremes with small amounts of people, and then we have more people in the middle eating that sort of medium amount. And medium is quite big, and then we have small amounts there. It's like a curve. This is called a distribution, or bell curve, or normal curve, if you want to call it that way. And you find these on everything. So if you are tossing a coin, how many times do you get a head? Well, some people will never get a head. We toss a coin 100 times and you never get a head. Not very many of those. Some people toss a coin 100 times and always get a head. That's a very small amount. But in the middle, we've got lots of people with about 50, 52, 48. A lot of people in the middle, and it tells. And then the more people you measure, the more focused in the middle it becomes. Anyway, it's just normal distribution. So if you imagine that curve of people in a group. So we want to find out, do men and women eat the same amount of ice cream? So that's quite an interesting question. So it's going to be a curve of how much ice cream women eat and a curve of how much ice cream men eat. Now the question is, do these curves overlap, which is at the very bottom end, men and women eating the same, at the very top end, men and women eating the same, and in the middle, we're eating the same amount? Or are the curves different so that the average group of women are eating less ice cream than the average group of men? Or what is it? And then how far apart are those groups? Is there a big difference between the amount of ice cream men and women eat, or is it a small difference? Now, the first thing we're going to think about is significance. Significance tells you the likelihood that the groups are different. That's it. It tells you nothing about how far apart this distance is, and that's a mistake people make. So let's take a look at this. Now, significance goes on a scale of 0 to 1. So if you get a significance of 1, that means that your 2 groups are 1. Now imagine we've got a group of randomly selected women, and we randomly pull these women into 2 groups, and we measure how much ice cream they ate. Now because it's all randomly done, you've got the same people in both groups. So yeah, their curves will just completely overlap. But if you take a group of women who are in the ice cream loving fan club and a group of women in the ice cream hating fan club, their curves are going to be different. Okay, so differences exist. So let's get back to the thing about significance. We run some kind of stats test. Could be a t-test, could be Wilcoxon rank, could be Mann-Whitney, does not matter at all. And we run the test. What we're looking at is significance, usually written as P equals. Now, as standard, you're looking for a value of below 0.05. So if you have a significance, P equals, of 0.05 or lower, then we say we have reached significance we are confident these groups are different. If it's above 0.05, you say, we can't prove they're different, we'll assume that they're similar. Why 0.05? Well, 0.05 means the confidence that you have that they're different. So 0.05 is 95% confident that there is a difference. If we had a result of 0.01, we'd be 99% confident that there is a difference. Remember, it's only we know there's difference, right? So you've gone up there, done a t-test on how much ice cream men and women eat, you get a significance score of 0.04, and you go, yep, a difference exists. Now here's a mistake everyone makes, and it drives me nuts. People think that a more significant result is a bigger difference. They go, oh, you had a group which is 0.04, oh, they're very close, very, very close groups. And then a score of 0.00001 and go, oh, they're really far apart, big difference. It doesn't work that way. That's not what it is. It's just the confidence that a difference exists. It tells you nothing about how big the difference is. For the size difference, you need what is called effect size. Effect size is a measure of the distance between groups. That's it. That's what it is. It's a measure of how far apart the groups are. So you run your test and you have a non-significant result, which is, your significance value, P equals 0.53. Okay, then you're saying, well, we're assuming the group's the same, they're overlapping. You would not bother with effect size because you are assuming they're the same. You calculate the effect size only after you've proven a significant result. So we know they're different. We want to find out how different. So you calculate your effect size. This might be the ETA squared. Every different stats test has a different one, different way of calculating it. I'm not going to go into that today. There's other videos on that. But your ETA squared, the bigger the value, the larger the difference. So if you've got a small difference, that's where it's, the groups are different, but can you really see them? Not really. It's really a small difference. It's very marginal. Do you even care about it? It's like if you're trying to cure a cold and you get a new drug, a new medicine, and that means you recover 1 day faster. Yeah, you're recovering faster. Great. 1 day, do we even notice that? It's marginal at best. So, and many people will recover faster and slower. So you probably wouldn't detect it because they're so overlapping. But if you find a new drug that cures your illness a week earlier, you would notice that. There's a big difference. So the bigger the ETA squared is, the bigger take notes. And the way you look at this is you want to look for medium or large effect sizes. Again, each form of ETA squared has different boundaries. There's other videos on that, what the boundaries are. If you comment on this video, I can chat with you about what these are. But basically, the ETA squared, you're looking for a medium or large effect size to go, yeah, there's a difference we can see. We can work with this. This is really good. So that's why significance is very important to know there's difference. But you've also got ETA squared, the effect size. That is crucial. You can't have one without the other. You've got to have the ETA squared to make sense of the significance.